Hey everybody, this is Mr. Conklin recording from home. This is going to be a very brief summary of what we covered on Tuesday, the 7th of September, about multiplying polynomials. It's going to be about 10 minutes, hopefully, plus or minus. Just a very quick summary. How do you multiply polynomials? First of all, a polynomial, maybe it'll be 15 minutes, we'll see. A polynomial is, if you remember, a sum of one or more terms. And there are two special conditions. All the bases have to be the same of each term, and all the exponents have to be whole numbers. All exponents are whole numbers. And what that is, starting with the number 0, 1, 2, 3, 4, and up. So it does not allow fractions or decimals or negative numbers, just 0, 1, 2, 3, 4, and so on. So a polynomial has to fit those conditions. How do you multiply two polynomials? Well, there are three basic ways to do this. First type, is a monomial times a polynomial. Now, from the previous lessons, a monomial is something with one term. A polynomial is something with one or more terms. Okay, so in this particular case, we're talking about, is that an M? Okay, good. That's supposed to be an M. I don't know if I put enough loops on my M there. I'm notorious for doing that. Anyway, a monomial times a polynomial might look like this. Quick example. It might be 3x parentheses x squared plus 5x plus 6. Okay, so we've got something in front, a monomial, a single term, and we've got a polynomial, a trinomial in this case, 1, 2, 3 terms. So how do you multiply a monomial times a polynomial? The main method is you distribute. Just a couple of refreshers on that before we actually start distributing. Rules. If you take, for example, x to the 6th power times x to the 3rd, you'd be tempted to say x to the 18th, but you actually add the powers together. This is x to the 9th. So you add these 6 and 3 together. One way to see that is to write this out the long way. This is 6x's multiplied together, and 3 more x's multiplied together, which make 9x's multiplied together. The other thing is if you have 3x times 5x, then what you do is you multiply the numbers first, which would be 15, and then you multiply the x times x, which in this case is x squared. Does it kind of make sense? So if you have, and technically it's 1 plus 1, which makes the 2. Same thing up here, x to the 6th times x to the 3rd is x to the 9th. It's not x to the 18th. That's a different rule altogether. So if you look over here, 3x, remember there's a little 1 here, and there's a little 1 here. I want to distribute this 3x into all three terms. So basically 3x times x squared. It might help if you remember, like people get a little confused, say, what do I do with the number? There's no number here. There actually is. There's an invisible 1 here. So you do the numbers first. 3 times 1 is 3. X times x squared actually gives you x to the 3rd. X to the 3rd power. Oops, I'm writing in a dent underneath here. Hang on a second. There we go. So 3x to the 3rd, because there's 1x coming in and 2x is already there. So when they combine, they make 3. So x to the 3rd. Plus 3x times 5x. Well, 3 times 5 is 15. And then x times x is x squared. Okay. And then plus 3x times 6. Do the numbers. 3 times 6 is 18. And there's only 1x total. And there you go. And that's your answer. Does that make sense? So if you have a monomial times a polynomial, you just distribute it in. Let me give you another one just to make sure that you have all the rules in place. Let's say this is 5x to the fourth, and then parentheses 3x to the third minus 10x squared plus 5x. How do we do that? We'll do the exact same way. Distribute, distribute, distribute. Sorry, I have a frog in my throat. Right here, I'm going to add the opposite because I always do that. And let's see what we can do. Again, multiply the numbers first, 15. Now, x to the fourth times x to the third. If you look over here at our rule, you add the powers. This is going to be x to the seventh. Let me get a quick swig of water here. Hang on. Yeah, much better. Plus, do the numbers first. 5 times negative 10. That's one of the reasons why I did add the opposite. So you can see it's negative 10. 5 times negative 10 is negative 50. And then x to the fourth times x squared is x to the sixth. Now with the last term, 5 times 5 is 25. X to the fourth times x, remember there's a single x here, x to the first, that adds up to x to the fifth. And that will be your final answer. Does that make sense? So anytime you have a monomial times a polynomial, you distribute. You just multiply the numbers first, then add the powers together of x, and you should have your answer. Okay. Method number 2, binomial times binomial. Well, what does that mean? In this case, you're talking about a 2-term polynomial and another 2-term polynomial. So let's see what it looks like. You might have 2x plus 5 times 3x plus 7. In this case, we're going to do something that's called FOIL, which is actually short for something. It's short for first plus outer plus inner plus last. So first, outer, inner, last to make FOIL, or the abbreviation FOIL. So what does that mean? The first means you take the first from each. So 2x and 3x, I'm going to mark that F because that's the first pair. By the first pair, I don't mean the first parentheses. I mean the first thingy from each. In this case, 2x times 3x. The outer, now if you notice, this is right in the middle here is the center of the problem. If you go as far out as you can from the center, you're going to hit 2x and 7. That's what I'm going to call the outer pair. I'm going to mark it with an O. So that's outer. Inner pair is just the opposite of that. You get as close to the center as you can, and the pair that's closest to the center is the 5 and the 3x. I'm going to call that I for inner. And then last, I have to squish it here. That means the last from each, the 5 and the 7. So I'm going to put that last. So what does this look like? Let's try it. It's going to be first plus outer plus inner plus last. That's how you do this. So you remember FOIL. That's how you remember the order. So first is 2x times 3x. So 2 times 3 is 6. And x times x is x squared. Plus. The outer is going to be 2x times 7, and that's 14x. The inner is going to be 5 times 3x, which is 15x. And then plus the last, which is 5 times 7, which is 35. Now we're almost done, but you notice these two middle terms are actually what we call like terms. You can combine these. 6x squared, you can't do much with it. Plus 14x plus 15x. Now don't add the powers. That's when you're multiplying. 14x plus 15x just makes more. It's 29x. Okay, that's from our addition and subtraction unit. And then plus 35, because there's nothing else to combine with that. And that is your final answer. That's called FOIL. So that's a way to do multiplication of binomial times binomial. It only works with binomial because that's the only way you'll have a first, outer, inner, last if you have two terms. Make sense? Now, I'm going to skip down to case 3 here. And I hope I'm not off screen. Okay, good. So method 3, polynomial times polynomial. So how do you do just any old polynomial times any old polynomial? There's a third method that's called stack multiplying. So what is that? It's a lot like the old-fashioned method of multiplying numbers. Let me give you an example. 312 times 21. Okay, so what I'm going to do is, this is kind of old hat, but remember, I'm just going to drill through this. It's 1 times 2 is 2. You put it directly underneath. 1 times 1 is 1. 1 times 3 is 3. Does that make sense? Now, the next phase is when you start from multiplying the 2. 2 times 2 is 4, but you scoot it over one space. Sometimes people just move it over. Sometimes people put a 0 here. That's totally fine. Whatever it takes to get this next row scooted over. 2 times 2 is 4. You scoot it over 1. 2 times 1 is 2, and then 2 times 3 is 6. Okay? Now let's add. 2 plus nothing is 2. That's actually why people like having a 0 there. 1 plus 4 is 5. 3 plus 2 is 5. And 6 by itself is just 6. So 6,552. So that should be old hat, God willing. Watch this. 3x squared plus 1x plus 2 time, I don't want to put an x because I'm using x's for a variable. 2x plus 1. So basically, somebody could have written in homework, it could look like this. 3x squared plus 1x plus 2, and then snug parentheses right up against 2x plus 1. Okay, it's the exact same thing. So how do you do this? Well, take the 1. You notice there's pluses in between every term. That's the only thing we have to remember down here. Otherwise, it's actually the exact same as over here. Watch this. 1 times 2 is 2. Just put a plus between things. 1 times 1x is 1x. Then plus 1 times 3x squared is 3x squared. See? I'm lining it up the exact same way I did over here. Now here, I'm going to scoot it over one space, or put a 0. That's fine. Start here. 2x times 2, just like I did the 2 times 2. 2x times 2 is 4x. Plus, then 2x times 1x, do the numbers. 2 times 1 is 2. X times x is x squared. Does that make sense? Plus, now 2x times 3x squared, do the numbers first. 2 times 3 is 6. And x times x squared is x to the third. Let's draw a line. Let's add them up. 2 plus nothing is 2, plus. Then 1x plus 4x is 5x, plus 3x squared plus 2x squared is 5x squared, plus, and then just plain old 6x to the third. And there's your answer. Okay? You've just multiplied some rather big polynomials, a trinomial times a binomial. You might also notice something interesting. You see the 6, 5, 5, 2, 6, 5, 5, 2. These are almost the same thing. It's just pretending that x is equal to 10. So more on that later. But that's called stack multiplying. So these are the 3 ways that we know how to multiply polynomials. Just for reference, for people who are listening to this on Tuesday night, we have not assigned the next homework yet. So I think there was 9E or something like that. Whichever one is multiplying polynomials, we're going to have that due on Thursday. So let me just double check and see which homework assignment we're talking here. We've got Algebra 1, homework. Yes. So it's 9D. 9D is in David. It is not due Wednesday. It is due Thursday. Thursday, September 9th, 2021. Okay. Everybody good? All right. Anyway, that's all I have for you. So anyway, take care. God bless. Wave goodbye. And we'll talk to you again soon. Bye-bye.